6.6 is on trapezoids and kites. Two additional special types of quadrilaterals. So a trapezoid, by definition, is a quadrilateral with exactly one pair of parallel sides. Let's draw one of these guys. The bases are always the parallel sides. The bases are the parallel sides. The base angles are the angles that share a base. So we have two sets of base angles here. Those two. And those guys will be congruent if and only if it's an isosceles trapezoid. So an isosceles trapezoid is a trapezoid with congruent legs. The legs connect the parallel bases. Or legs connect the bases. So, some properties of this. Notice that we are out of the land of parallelograms. So all those properties of parallelograms no longer apply to trapezoids and kites. So a trapezoid is isosceles if and only if the diagonals are congruent. And this is similar. Remember, rectangles have congruent diagonals, but isosceles trapezoids do as well. So if you had A, B, C, D, A, C is congruent to B, D. So PQRS is an isosceles trapezoid. The measure of angle S is 50 degrees. So that's 50 degrees. Find the other three angle measures. Okay? So isosceles trapezoid, we know base angles are the same. So R also has to be 50. And then P and Q. We know that the sum of all of the internal angles in a quadrilateral always add to 360. And we know these are the same measures. So 360 minus these other two angles is going to equal the sum of these guys. I'm going to call those Y in there just to make it nice and easy for us. So equal those other two. So I have 260 equals 2Y. Divide both sides by 2. Y equals 130. So measure of angle Q equals 130. Measure of angle P also equals 130. Next, find the value of x. These guys are congruent. 3x equals 12. X equals 4. Isosceles triangle or trapezoid means that those legs are congruent. So find y. I already used y. So find y if s cubed. So s cubed. That whole thing is 22. And PR is 7x plus 1. And then I saw these trapezoid diagonals are congruent. So I have 7x plus 1 equals 22. 7x equals 21. X equals 3. Should say solve for x. Question on those. All right, the next big idea is the idea of mid-segments. We remember mid-segments and triangles, right? Mid-segments and triangles connect the midpoints of two sides of the triangle, right? And we remember that they were half as long as the third side, parallel to the third side. So the mid-segment of a trapezoid is parallel to each base. So it's parallel to the top and the bottom. And its length is 1/2 the sum of the two bases. So it's the average of the lengths of the two bases. So we have a mid-segment here. So in order to find this x, 6 plus x divided by 2 equals 9. And then algebraically, that's real easy to solve. So the top and the bottom go up top there. And then the mid-segment length there. So I'm going to solve this, multiply both sides by 2. 6 plus x equals 18. And then I'm going to subtract 6 from both sides. I get x equals 12. See if you can do example 3. Set up similar but slightly different. Try example 3. So remember, the mid-segment is the average of the lengths of the two bases. So I'm looking for the mid-segment length. So that's what I'm solving for. So I'm going to add 14 plus 4, divide by 2, and that'll give me the length of the mid-segment. Y equals 18 divided by 2. Y equals.
Oh, see, that's good. See, I was
All right. Next definition.
Wait, what was the difference when you multiplied the first one by 2?
I was solving for this x on top, so I don't.
Oh, so when you do that, you have to.
Right. This is just numbers over here.
Yeah. So when there's x.
Well, you could multiply both sides by 2. 2y equals 18 and then divide. All right, so a kite. Another quadrilateral. A quadrilateral with two pairs of consecutive congruent sides. Also, not a parallelogram. Two pairs of consecutive congruent sides. Draw your tight like that. Okay.
So don't you know? I did.
A quadrilateral is a kite, then the diagonals are perpendicular. Another property that's similar to squares and rhombuses. So, one of the properties, diagonals are perpendicular. Making these what type of triangles? Right triangles.
Oh wait, no.
And then we have two pairs of congruent right triangles in there. And then if a quadrilateral is a kite, then only one pair of opposite angles are congruent. So across the short way, those guys are congruent. The long way, another property is these guys are bisect the long side. So these angles are bisected. All right. So find the lengths of the sides of the kite. All right, so these two are congruent. So that's 8. This is 8. This long one's 20. What type of triangles do I have? Right triangles. So let's go ahead and solve for our sides. We'll make this x and this y. Whenever I have a right triangle, and I want to solve for those missing sides, I'm going to use my Pythagorean theorem. So go ahead and set up and solve your Pythagorean theorem. You should have a calculator handy. All right. So this one, we're going to set this up. 8 squared plus 20 squared equals x squared. So I have x squared equals 464. And then I'm going to square root that. And I get 21.5 as that side. And then 8 squared plus 12 squared equals y squared. And I get y squared equals 208. Square root that. And I get y equals 14.4. This one's good to know how to use your calculator. Use the square root button in this unit. All right. Let's identify the unknown angles of our kite here. So remember, we're still in quadrilateral. The sum of all the angles inside a quadrilateral always equals 360. For a kite, angles opposite the two sides that are not congruent are always congruent. So that is 120. And then this angle, we'll call it angle X over there, is going to be 120 plus 120 plus 80 plus X, all equals 360. So 320 plus X equals 360. X equals 40 degrees. So this guy right here, 40 degrees.
Why is it 6?